Hi everyone, today we're on to the next shape, which is an ellipse. So the story begins with a circle, which we've already seen. It's a set of points equidistant from one fixed point. The fixed point is called the center, and the equidistance or the distance is called r. And we also saw, like in terms of equation, that a circle is a special form of an ellipse. Now, to define an ellipse geometrically, instead of one fixed point called the center, we select two fixed points. We label them F1, F2. And the question is, what is the set of points whose sum of distance from the two fixed points are constant? Okay, because we have two fixed points, if I just say that points which are equal distance from these points, then that's just going to be a straight line, right? Where these distances are equal. In fact, it's going to be like the set of all isosceles triangle. So in order to get the ellipse, instead of saying the distance from both points are equal, we're going to say that the sum of the distance is going to be constant. It's not going to change as you go around. So slightly different kind of definition. And these points, the fixed points, are called focus or foci of the ellipse. And any point P, then the distance from both of them is the same. So the sum of these two sum of black lines is the same as these two sum of blue lines. And you can sort of imagine like what happens if these get closer and closer. If these get closer and closer, if they are closer, then this sum equals this sum. The ellipse sort of closes in, and then when they become one point, then it just becomes a circle. So geometrically as well, you can see that if you take an ellipse and you make the focus sort of collapse, then it becomes one fixed point and it becomes a circle. And again, as with parabola, let's try to derive the equation. So we put this into a coordinate system. For simplicity, again, just as we did with the parabola, saying the vertex is 0, 0, we set it up so that the origin is exactly in between the two vertex. And we call these negative C0, C0. And it says the distance of any point P from F1 and the distance from F2 is a constant. And this constant, we're going to give a special, we're just going to call it 2a. Okay. And that's because you take the constant to be like a k or something and you get a bunch of fractions, and it turns out using 2a makes things easier. So let's write this distance, F1P. So this is a right angle triangle, right? So right here. This length is 2c. This height here, what's that height? The height is y. It's actually, we can use a distance formula. So that would give me x plus c squared plus y squared plus x minus c squared plus y squared equals some constant 2a. So this distance pf1 plus pf2 gives me a constant. I'm going to send one of the square roots on the other side, which is a technique for solving these kind of equations from Math 103. X minus and then square both sides. If I square both sides, I end up with x squared plus c squared plus 2xc plus y squared here. So it's going to be a squared plus b squared minus 2 times the first term times the second term. So 4a squared plus x squared plus c squared minus 2xc plus y squared minus 2 times 2a, which is 4a, and square root of x minus c squared plus y squared. Now let's see if some things cancel out, which they should. X squared minus x squared is 0, c squared minus c squared is 0, y squared minus y squared is 0. So that is good. Now this is negative. If I take this to the other side, I get 4a squared minus, so I send this here, and I send this here. 4a squared minus 4xc equals 4a square root of all of this term here. Now we can divide by 4, because there's a 4 term on both. So I get a square root of x minus c squared plus y squared equals a squared minus xc. Right, let's just check if everything is correct here. Yeah, it seems to be fine. Oh, this is a plus here. Let's see, did I mess up some signs here? Oh, right. Squared minus 2x squared minus 2y x plus, so that's that, and then I end up with a minus. Okay, let's just go ahead and square this. That's a squared, and I get x squared plus c squared minus 2xc plus y squared equals a squared minus xc squared. I distribute this, get a squared x squared, a squared c squared, 2x ca squared, a squared y squared. A squared squared is a to the 4 minus 2a squared xc plus x squared c squared. Now what can I cancel here? This gets cancelled out, which is good. Let's collect all the terms I have. So I subtract x squared c squared from this side, so that's c squared x squared, and from this side I subtract a squared c squared, a squared c squared. So I get x squared times a squared minus c squared plus a squared times y squared equals a squared times a squared minus c squared. Okay, now let's look at these values of a and c. Right, this distance is 2c, and the sum of these is 2a, right? So we know 2a is more than 2c, so this is going to be positive. Let's divide by a squared times a squared minus c squared. Then this becomes x squared over a squared plus y squared over a squared minus c squared equals 1. Which then is our familiar form. If I let b squared equal a squared minus c squared, this becomes x squared over a squared plus y squared over b squared equals 1. And that's the familiar form of equation of an ellipse that you've seen before. Okay, so the derivation here is slightly more involved because it uses squaring 2 times and factoring and stuff. So I would recommend that you try and do this derivation on your own. And I'm going to end this video here, and we look at more examples and more terms in the next video.